Hey there, can you see me? Katie?
Yep.
Okay. And can you hear me okay? Is there an audio problem?
Nope. Sounds good.
Okay. And is the video different and better?
I think so, yeah.
Yeah, I just invested in a new setup that makes it look different than the one I had before was kind of lame. This one is professional. It shows the full video. It focuses on me from an angle, and yeah, it should be good. I hope it will be good because this is uh, supposed to be good. I guess so. That's how I would say. Hey, Chris. There we go. We have Chris there. Hello. Can
Hey.
you see me? Hey, can you see me?
Yep, just fine.
Any different today?
You combed your hair? I don't know.
No. Yeah, I have both of them. I comb both of them. One at a time.
Is it a different camera? Is that what you got?
I have a left hair and a right hair.
Oh, okay. Yeah, very nice. Very nice.
Yeah, that's what I do. So, yeah, I responded to your message, Chris, that you may have seen already. And so you should, we should get together.
Yes.
Have coffee. And so I am going to project my desktop, and there we go. So we have our remote desktop connected. Not yet. There we go. That should bring up a virtual machine as we go along. And hey, Sandeep, how are you doing? I can see Sandeep.
Good. How are you?
Good, good. So, okay, we have, I think we should start. So let's quick recap on the last time and finish towards the discussion we had with Ansible. There was a question that came up, I think, in the topic of Ansible, which I would like to cover and discuss and explain. But the way I prefer to use Ansible is to prepare infrastructure for ourselves for use with Docker. That's the primary use case that I currently use. And as you know, we have been discussing these things as we go along. We have been using this OneNote was going to get a bad review from me just like right now. It asked me for a rating of OneNote. It is actually a good product, but I don't want to rate it right now. But I'm going to be evil and give it a rating of 0 stars. No, yeah, I'm not doing anything like that. So what I'm going to do right now is to stay focused on what we are discussing. And with that in mind, erasing and making room for our discussion to start. And we used this tool set called Chef quite a bit. We started practicing Ansible a little bit. And our ultimate goal is to understand these toolings. And there is another one, by the way, that I actually prefer to use is called Docker, which is where we are transitioning towards primarily, because these tools help us in putting components and pieces together to assemble a solution of some sorts, a solution that will represent an architecture for a given customer situation. That's what really we want to assemble, is to put together a piece of design, a piece of blueprint that forms a solution for a given customer problem. And we want to really accomplish that thing for a customer, for which we require a variety of components to fit things together to accomplish a solution. And so we practice this quite a bit, and we are going to do more of this today. But we are eventually using these toolings to set up these guys, Docker as a container technology, which is essentially how the world is evolving, right? As you know already, is using containers is the modern way of running applications and services, as opposed to using these virtual machines that we occasionally play with. Like I am currently running this one right now, and you have it. And we have been playing with virtual machines all along up until this point. But we will slowly transition our discussion towards using containers, and slowly and very steadily. That's what I want to do today is to finish off the exercises we were doing the last time. So I'm going to log in and get to that point where we were. And from that point onwards, what I want to do is do a couple of exercises using Ansible to give us a flavor of how we can put Ansible to use in the context of a real life example. I will describe that example to you. The last time we were about to begin a complex exercise, which is what we will actually do today right now as we begin. And that exercise enables and makes sure that our infrastructure is inherently secure by design. And that security aspects is what we have attempted to put together in form of this Ansible exercise, which actually enables and makes machines secure and harden. So this is the repository that I want to play with today. I will take that repository and go to this workstation where we have that repo already, if I remember right. So in that repository, if you go look at the listing, I think I may have it already here. Yeah, I think it is the Ansible example maybe. So I think it is the Ansible example is what I think I have in mind, but I want to confirm. So yes, that's the example file that we are working with. And I'm going to open it up and reset its Git repository back to ground zero, because that will help us in accomplishing a clear idea about how do we make use of that repository. So we have made some changes the last time. I'm going to reset the whole thing back to ground zero and then begin understanding what these things do for us. So that is what my plan is for today, is begin from fresh and quickly get to a point where we can make use of Ansible to harden, to make a box secure, to make a box exactly like how I would like it to be. And I'll do this step by step, and you can probably follow along. It's an exercise. You can actually do it together with me. And so that's what I would suggest, actually, that you do this together, so you will understand what things are and you can tweak to the way you like, just like exactly how you would like it to be. So to begin, what I'm going to do is remember that I am going to use this repository from this location. That GitHub location is number 6, this line number 6. That's what I want to grab. And I will like to put that in this location. So I can clone it, basically git clone. But since I have already cloned, I want to bring it back to the point where it was to begin with, like at the beginning point in time. So I'll do a git reset. So this reset basically simulates a new clone, a fresh clone. So git reset hard will basically reset this entire project as if it was just freshly cloned. And all these file content that you have here are basically exactly what you see in the GitHub location, which is this location shown in line number 6. The same thing I have here in terms of these files: Ansible configuration, a file containing my hosts, this is the inventory of all the machines I have, and a file that describes a playbook. Now I will go through this playbook, but I will introduce, this playbook is long, like 50 or so lines. So I'll introduce elements to the playbook line by line as we go along, like item by item. And that's what I intend to do, as opposed to running the whole book at the same time. What I intend to do is copy the whole thing, like copy the entire playbook and keep it safe somewhere in a temporary location like this. I'll keep this safe. So I'll rename it, save it as, and save it in this location. Let's say the user folder. I have the Ansible example. So in this location, I'm going to just save it. Call it saveit.yaml. I'm not actually using it, but I'm saving it in a separate file. That is this saveit.yaml in green color. That is what I intend to just keep it safe. It's an exact copy of what we have currently in the user YAML. And you can see that by comparing diff user YAML and saveit YAML. It is the same exact thing. As you can see, there is no difference. Now, having done this part, I would like to now make some location of a new machine that I want to make it secure, make it hard to break for hackers. And those changes I need to make to a target machine, that machine I will need to obtain, which is the IP address will go in that location. So that location IP address is actually a dummy location. So I'm going to put the real IP address right in there. I would like to make sure that the new machine I get has the correct username. So the username I will have to get to begin with is typically called root. That's what most companies give us, except some companies choose other names as we go along. And since we are going to use a private key, that private key file is this label that we have there. And we also want to use a version 3 of Python, whereas Ansible doesn't yet directly, explicitly by default, does not yet support Python 3. It has to be explicitly called out. And that reference, as you may recall, is available from a separate command line argument that we had to pass in the host file reference. That is labeled as Ansible Python 3. So this is a change that is happening in Ansible that will eventually get picked up. But that support for Python 3 has to be called out in form of a line like this, Ansible Python interpreter. A line like this has to be explicitly passed in the environment. So we can do that same thing with a -e option by enabling this line, Ansible Python interpreter user bin Python 3. We have to copy this location, this item, and put that back into our host reference right in there, in the same line at the very end. I'm going to paste it, which tells this particular host should be using Python 3 as opposed to Python 2 by default. And that change is what we are making. Remember to not copy any other character apart from the one that we expect to have. So there are no quotes at the on the both sides of this particular statement. I just pasted it into that file called host file, and this host file now is in its shape that is usable. So I'm going to paste this file for you to be able to also use as we go along. And I think I already have it right there. So this is the file in your Slack chat. You already have there in Slack. So we'll use that kind of a structure, put that in our host file reference. We'll call it a group called web, for example. And that web group is what I want to add to our host references here. And I will go all the way to the beginning and say, this is my web collection of machines. I'm going to call this Ansible example or no Python v2 or whatever name you have. And then I will get a real machine, a machine for real. For example, I will go here to my cloud and say, get me a machine. And so it gives me a machine, and I will get something in Seattle and choose Ubuntu, and I'll choose the modern LTS 1604, and I'll get a small size $25 machine. I will also do a couple of interesting things, which is, I have never done that before, but I will do this now, is to not select a key at all. It's like these SSH keys that we have been selecting, I will deliberately not choose anything. And the response that I expect from this guy, from this cloud, is that it should generate a password for me and email it to me. That's what I expect, because I have not chosen a key here by default. I would expect them to give me a password. So I did deploy without a key. And that's what I would expect, is that I get an email saying, hey, we got a machine for you. Here is the password. Because I did not choose a password. That's the typical behavior I expect, but something may be different. That, by the way, happens here in this cloud. If you go and log in, you will see that DigitalOcean will actually give you an email containing your root password if you start a machine without a key pair. And that is not true in case of Amazon. In case of Amazon's example, if you go here and say in EC2, give me a machine, it will let you create a machine without a password, without a key, and will not email you any password either. That's the difference. And you can debate whether what is good approach or not. But bottom line is that if you using a password with your machine, that is a bad idea to begin with, because it's inherently insecure to have a password. So now that this machine called Ansible example is installing and starting up, I'm expecting to get an email containing, hey, here is your password. And that will happen eventually when it does. But what I'm really talking about is this idea that if you have a machine that you can access, you should access that machine without a password using a key pair. That's the ideal situation. But I have deliberately, in our example that I just started a new box, I said, give me a box without selecting any key pair at all. I did not choose one. So they're going to assign me a root and a password. That's the assignment I'm expecting to happen. And this is a bad idea at multiple levels. First level, we are using password. Password is a bad idea. This is bad idea number one. Bad number two is that we are using root login. Using root login is also a bad idea. So don't do that. So we are going to prevent these ideas. Like using a password, we'll disable that. Using a root login, we'll say don't do that. But then how do we log in? So we have to have our own user, right? So we have to create a user. So a good idea is here. So good idea would be that you create your own user. Create your user. And then with your password. But then again, I'm repeating this bad idea, right? Don't use a password. So I will create that password because that's what Unix expects, to have a password, but then I will disable this password. But then if I disable the password, how do I log in? Before I disable the password, I will make sure that another good idea that I would like to do is to make sure that I enable passwordless access using SSH keys. And so I will create my user, my password, but disable the password because I'm going to provide an SSH key. And so these are the basic things that I want to enable. Once I have these things in place, then I want to disable root login and also disable this password for the root user. And then I will disable a variety of other things. So you will see those things written down in our example in that location in GitHub in form of an Ansible playbook. And Ansible playbook are the ways to write ideas, documentation, essentially. That's how I look at Ansible. It's a way to describe these ideas, like, disable this, enable that, accomplish this, accomplish that, do this, get that done, install this, make that setup in exactly the way I define. So these ideas that you want to write down, you want to specify in succinct language how and not how. What do you want? The how part is taken care of by the other things like playbooks, for example. But you have to declare, what do I want? And that piece, you have to write that down succinctly. And once you do that, it will accomplish that succinct descriptive, whatever you write. And that is typically written in a YAML file. You write that down. I would like to have this and this. And so these tasks, or the accomplishments, or the end results that you want to accomplish, will be implemented step by step, task by task, item by item, play by play, as variety of people call these different names. So I think Ansible uses the word play. So it will play by play these items in your YAML file and accomplish a result for you. So the way I read YAML is more like documentation of my design. What do I actually want to accomplish? So this is how I think of YAMLs as you go along, is a way to accomplish a end game, a goal, a desire. That's how I like to look at, or rather think of YAML in that context. So if you go now and compare with what that playbook here, which is here, this particular repository, what do we have? Let's go see what it does. So you will go to GitHub and find that out. And that it contains exactly a user YAML. This YAML is basically I think of it as documentation. So I'm basically defining my variable called Cloud Genius password to be this value. This is my password in shadow form. The shadow is created using this structure. And then I actually pass my password like that. Then I have a variety of tasks defined. First, task number 1, task number 2, task number 3, like that. And so what I want to do is help you understand how you write and these task definitions, how you write them, and how you enable and invoke these things onto a given target machine. And our target in our mind is hosts called Ansible example. So that's the host I want to target it against, which means that host file that I have in our example should be called that name. So if you go to our host file, which is this file, it should be looking at this file called Ansible example, which is where this machine belongs. And it needs to have a IP address, which I have not yet given. So I need to go and grab the IP address from this box, which is right here. So I'll take that IP address. I'll put that in my VM. So this is my VM's IP address now. I have it and I save, but I still don't have my password. And I don't have my access key either. So this access key I have not used. So you remember that this is not going to be functional because I'm not using it in this example. And typical situations you might run into a situation where you're not set up with a key pair at all. And that is what I'm trying to simulate by not giving a key pair to our cloud provider to begin with and expecting them to generate me a password. So this key pair will not be useful. So I'm going to remove it. I'm going to make it ask me for a password. And that password request will happen. But in the meanwhile, let us see if this particular cloud has given us a email containing our password. So I'll go and check my email and let us see if they have sent me a password. I hope they did. If not, we'll have to find some other way to get that password, because without the password, there is no other way. So it should have told us that, hey, here is your machine, which I'm expecting. So here it says, hey, you got a machine there. And oh, it says initial root password. Okay, hold on, where is that? In the email that I have, it says this machine is created. And it further says that you can access your machine. Oh, hold on. You can access your machine using SSH. I understand that. And initial root password to your server can be found in your control panel. And we recommend that you change it. I said, good. Thank you for telling me where to find my password. So here is the machine. It should tell me my password, and it's right there. So I can copy my password, click. So I have it now. I can see it, and this is my password. So they told me the password. Now I have to connect to that box and make it secure the way I'm discussing. So first of all, I will just keep that password in mind. So I have it, and then I will look at my playbook. My playbook is this playbook that I want to see. So I'm going to use this as my password and also create another user. So that's the first task we have here, is to create a user called Cloud Genius with a password called this password, which is this 123. And that's the Cloud Genius password shadow that I'm passing along as my password, and will give me a shell called bash, make me a member of the root group, and create that account in that machine. So if I run only this segment of lines number 14 and 15 against the target, and at the same time remove anything else. So if you go back to our workstation here and say this machine should run me only this particular segment of the code. For example, user YAML. So I will keep only lines number 14 and 15, and rest of it I'll delete. I can delete because I have a copy of that safe in another location. So I'm going to run just this particular playbook right now, only this portion. And while doing that, I want to actually check whether I can connect to that machine right there. So here is my machine that I want to connect to. I'll say SSH root at, and then the IP address of that box is here. So I'll grab that IP address right there, and I will copy it. I will go here and say, paste the IP address, and I'll attempt to connect. And it says, are you sure? And I say, yes, and now give me the password. This password is what we have to obtain from that control panel, which this location provides me right there is my password. So I'm going to copy that password just like that. I hope it copied correctly. I will verify that in a notepad. So in our notepad somewhere here, I will say, open me a new file and paste. And so it looks like I copied correctly. So that is my password. I'm going to provide my password right here to this guy and say, hey, here's your password. So it says, yeah, we got logged in. Now, this is a fundamental thing I want to fix. Don't want to use the root user. But if I disable the root user, then I cannot even get in. So I have to create another user first. So let's do that piece. So I'll come out of this box and run the Ansible play called user. That one, just this one liner. Create me a user, please. That's all it does. And so I'll play this play on that target by basically invoking something like Ansible playbook, play me the user playbook on the target machine. And so the scenario is as simple as running Ansible playbook and the book name, which is user. That's it. That should ask me for a password. It did not. It says permission denied, unreachable. Message failed to connect to the host by SSH, permission denied. So we have to ask for the password explicitly like this. Ask sudo password. Typing mistake. Ask sudo dash password. And so now it is asking me for the root user's password, which I have in my copy buffer. I will paste it. And this should now, it again fails. Unreachable. Permission denied, public key, password, unreachable. Am I pasting my key correctly? Yes. I'm pasting my password correctly. I'm saying, what is the user host name? Is it root? Let's check the host file. Is that username is root? And it is running Python 3 and the host name is correct. This is wrong. This is bad. Something is bad. Okay. This is lame. I don't like it. If it doesn't work, I obviously don't like it, but I have to figure out something as to how would I make it work for you. And that is what I am going to do right now is start another machine. This time I will use an SSH key. So the key that I have this machine, first of all, I will destroy it. And I'll say, yes, please go away. This particular scenario that I'm playing, this machine is going to die. I'm going to start a new machine. Servers, please get me a new computer right there. And it is going to start a new machine in Seattle. And I will get Ubuntu for 16.04, a $5 machine. And I will actually select the key I have, which is this, and give it a name. I will give it this name, same name again. Actually, it doesn't even matter. But I will now deploy. So this new machine gets started. And I should be able to connect to this machine with a key pair that I already have. So the discussion I have about passwords, which I was trying as it was the first time I already tried with using just a password without a key. And it did not seem to like it. Ansible did not like it for some reason. I don't know what. It may be Python 3 issue. It may be anything else that I do not yet know, because these things are in flux. As I told you already, Ansible is new. And Python 3 is even newer for Ansible. That may be causing issues. These issues are going to be overcome. The way I think about Ansible using today is to work with Python 2. That works out okay, which means we have to go revert one step below 16.04 and stick to 14.04 Ubuntu. Things work out okay. And I've been using this all the time, as you know, and you will see examples as we go along. And I hope they work for me. That when it doesn't work, it just sucks. And I hate it, of course. So I'm going to delete this email. And I'm going to expect another email coming in pretty soon, which is going to tell me that this new machine is starting up or started. It is running apparently. So I have this new email, this IP address, and I will not have a password because I don't need one. So I'll go back to my VM and say my host IP address is now changed. And the IP address is this. So I will remove that IP address, place this new IP address, save, and then I will go back here, remove my known host file, which is in our .ssh folder, known host file. And then I want to play the playbook one more time. And it should not need a sudo password ask at all. It should just run. And let us see how the response is right now. It said yes, succeeded. So what does that mean? It succeeded in doing one thing. It did what? The only thing we had in our user YAML. And the thing we had was to create a user called Cloud Genius. So that piece succeeded. What it did was created a user. Let's go see whether it actually did. So I'm going to put this on the side here and this on the other side and connect to that box. Connect to this particular IP address that I have. This IP address is, I'm going to copy that and bring it here. Try to connect to that SSH root at should succeed already without a password because I have the private key, public key pair. So this succeeds. Yes, I exit. Now I want to connect to the same box, SSH Cloud Genius at IP address. Now this should also succeed because I know I have created a user. And the password for that user was provided in the user YAML. The password I chose was this line number 10, which is a shadow. A shadow for what? For the numbers 1, 2, 3. That's a shadow. So the actual password is 1, 2, 3. That's what I chose in this machine. So I should type 1, 2, 3, and it should let me in. And it did. Good. Now we'll expand our scope of the save it playbook contains a whole lot more than just this creating a user. So I want to add this user and get me super user privileges, which by the way, I do not have right now. If I try to run as login as Cloud Genius and say sudo apt update, it will say, I'll type in my password 1, 2, 3, and it will say, you don't have permissions and the incidents will be reported. So yeah, it says Cloud Genius is not in the sudoers file. This incident will be reported to Santa Claus. Oh, that Santa Claus was a joke. But that's what happens, right? You don't have permissions to become a super user. It makes a log entry basically. So it says, yeah, somebody attempted to log in as a root. Somebody attempted to escalate privileges to super user, and they were not in the sudoers file. So that's a log entry. This incident will be reported to Santa Claus, whatever. So we are going to add ourselves to the sudoers file so that we become, this Cloud Genius user becomes eligible for escalation of privileges. Right now we don't, as you can see. So I'm going to come back out of this machine, out, and back in our workstation. I'm going to play the play again, but this time I will expand my play to add this segment. What this segment does, as you know already, is to enable privilege. But how it is going to do, that's what I want to just make sure that I help you understand. And so what I'm going to do is add this segment into the user YAML, which looks like this. And what this segment does is uses the line in file module and adds a regular expression that looks like this into this file called etc sudoers. So where is that file? It actually exists in this computer, remote computer, somewhere in etc sudoers. The easiest way to see it visually is vi sudo. And that's where you can see that the file contains entries to allow members of the group sudo to execute any command. You have to write something like this, expression like this, to allow you to become a super user, a member of the super user privileged group. And so that's what we have to make a change, but I don't want to change it manually. So I'll exit it from here. I want to come out of that machine also. I want to execute that change in a systematic fashion using Ansible. So I will make that line in file module, put that to use, and include this line in the sudo file, the sudoers file. That's what I will enable by running this particular play, now expanded to cover two things. So that's what I have. I will save that playbook and play it against our target machine, which is going to play like this. Ansible user, play my playbook containing two things now. First, create a user. Second, put that user in the sudoers list. So I will run this playbook, and you can see that it runs. It does two things. The first one, it will skip doing because it's already done. There is no need to create a user. The user already exists, so it is green colored, no change there. Here, this thing was needed, so it actually does that change and puts that user, Cloud Genius, to the sudoers list. Now, this user, Cloud Genius user, has privileges to escalate to super user if and when needed. So now we'll go connect to this machine. I will connect to this machine in the command line, pretty much like Cloud Genius user. And now I will provide my password, which is 123. And then I see that I can log in. I'll try to run update apt cache, which requires escalation of privileges. So I'll say yes. It says, okay, here it is. It already done that part. We can, basically we verified that we succeeded in getting our privileges escalated, and this sudo command succeeded for us because Cloud Genius is now a super user in this machine. So we expanded that scope. We'll further keep adding these things as we study making our box harden. Now that we have added our Cloud Genius user to the super user list, I want to add one more capability to the Cloud Genius user, which is to make this Cloud Genius user not use a password. And you can enable that by basically, if you try to run and connect as Cloud Genius, it says, give me a password 123, which is bad idea. So I don't want to use the password there. So I will have to come out of that machine and run Ansible in an expanded play, which includes this segment, the blue highlighted segment. What it does is puts a public key into the right location for the Cloud Genius user. And that's what I intend to do. So I'll grab my user YAML and add those segments of line that I have copied pasted from the original file. And this expanded scope includes adding a public key to the remote user called Cloud Genius. So that user, Cloud Genius, will get a public key included in the authorized keys folder. Authorized keys file in the machine inside. You can see that. Right now, you can go and examine that particular user. We have to type in the password 123. And if you go to the .ssh folder, it doesn't even exist. There is no such folder called .ssh. So now that folder will have a file called authorized keys, and that's where our public key will be placed. That will happen when we run the play, the expanded play starting from line 24 through 27. And that you can see here, if I run my playbook again, it will do three things, two of which are no op. The third one is actually actionable. So this was already done, added user, already added, add user to super users, it was already done, so nothing to do there. The third one was add public key to the remote user. So this user called Cloud Genius has now a public key that we have provided to that user. So we should test. So I'll go and open a terminal, go to that location, and there I will SSH connect using the Cloud Genius user and the machine's IP address, and attempt to connect without having to provide a password. So I'm going to explicitly call out my public key. So I'll say use my public key, or use my private key, please, here. And so it should just connect, which it did. I know my password is 123, and it connected without prompting me for my password because I provided my private key already. Now we'll keep expanding this. By the way, let me come out of the machine. I'm coming back to my workstation, and I'm going to expand further ideas ahead. What I'm going to do next is another step, which is I want to disallow. Now that I can connect to the Cloud Genius user and I can connect to that machine without having to type a password manually, even though I have the password, I want to disable the SSH access for the root user. The root user should not be deleted. It should exist, but then it should not be allowed to access a machine via SSH while the username is root. So root user should be prevented from connecting to the box at all. That is possible, provided you disable certain things in this file called sshd-config. You have to go to that destination file in etc that particular location, etc ssh sshd_config. In that destination, you have to modify some characteristics, some specific parameters. What you have to do, I'll show it to you right here. You have to go connect to the machine. And in that machine, you go to etc ssh. And in that folder, you will find there is a file called sshd-config. So you have to modify that file, sshd-config. And you have to modify that, you have to modify that automated fashion, not mechanically. Don't go here and muck with the file directly yourself, although you could. Nothing wrong with doing that one or two times, but you have to do it in a systematic fashion. So you have to go look for a particular line entry that looks like this, permit root login, and say no. So I'll go look for it. There is a file called, there is a line here called permit root login, and that is what I want to say no to it. In our terminal, I'm going to find it, permit root login, and there it is. It says permit root login yes. I want to say no to it, and I will say that no systematically, not here, not right now. I'll say quit, and quit from the machine itself. Come back to our workstation, and I want to do that thing in this Ansible way. So what I want to do is make that change. Take this segment of the code from the safe file that we have to disallow root access, and we are basically using this line in file segment. And what this does is looks for a regular expression that begins with the word permit root login and make that particular line look like permit root login no. It typically says permit root login yes. We want to make it no. And when we modify the SSHD configuration, it is necessary for us to restart the SSH daemon server, the backend daemon that runs SSHD configuration on the remote box. We have to restart that. We can do that by notifying this handler to restart SSH. And that handler is the very bottom. You will find it written. It says to SSH service should be restarted. It's declarative again. So it declares the state should be restarted. The service name, SSH, state, restarted. That's the handler purpose. So you have to grab this handler first and copy that into our user YAML at the very bottom, and then save it. We'll also copy the other segment of interesting piece of code that I want to grab, which basically prevents the root user from logging in at all. So that segment of code, if you go and see that segment, the good thing is that these pieces of code are really, really easy to understand. It's just a few set of lines that describe, that declares the state that you want. So we'd like to have in that line in file, you want to modify this line in that file. That's it. And we want to modify that line in such a fashion that the permit root login becomes no. And such a line should be present. The state of that line is it needs to be there. A line containing permit root login beginning with the letter permit root login. So this is a regular expression written in a fashion that shows that it has to begin with the letters PERMIT root login, like that. So anywhere you find a line containing permit root login and it has yes or something else, it will remove that line and put a new line in there that says permit root login no. That's what you need to happen. And that's the segment of code that will make this thing happen. And when it changes that, it will notify SSH server to restart. So that we have these segments in place. So we have added the Cloud Genius user, added that user to super user privilege, added our public key for the Cloud Genius user, and now we are trying to disable SSH access for the root user. And this is, of course, a good practice. You don't want root user to connect to your box remotely. You want only you to connect to the box remotely. And so I am going to save this change, by the way. And then I will also quit out of that save it file. And then I'm going to run this particular play. The new things in here this time are lines 29 all the way through 36. So that play, when you execute, you'll say Ansible playbook, play my play. It'll do all these things, but find that this was unnecessary, so it doesn't do anything. Again, another unnecessary, 3 unnecessary steps. So it skips them. No need to create a new user, already has it, all those things. Public key already has it. You want to disallow root access for the SSH access for the root user. That action of disallow was an active change. What change did it do? It modified that file, SSHD config file, this file, and modified to make it say no. As a consequence of saying this no, and you restart SSH, which it did. So there are 2 changes. As a consequence of doing this, if you attempt to log on to this machine by saying root user, it will reject. So I'm going to attempt to access that box with the root user. That's how the machine was originally created. It had access, and I will attempt to connect, and it says, give me the password. And we don't have the password because there is no such provided to us. So if you attempt to provide a password, it will fail because I don't even have the password for the root user. It will keep asking for that until you fail out and says permission denied. So that step you are noticing that you disallow root access, SSH access for root user. So we did that piece. We'll expand this further as we keep going out and adding more segments of interesting tidbits. Here, imagine if somebody has access to figuring out that password that it is asking for, we want to even prevent that. So disallow SSH password-based authentication. So I know my password for this box is 123, and I know that I can figure out a password for this root user by maybe visiting this website, or no, not this. By visiting this website, I can go to the Ansible example page and somehow figure out the root password is here. That's my root password, right? I can probably log in even right now. I want to prevent all these things already. How do I prevent that? I prevent these things by disallowing use of passwords to begin with. Nobody, including me or the name Cloud Genius, will have a way to connect to any box whatsoever. This box, not any box, this box should be completely disallowed if you are trying to access using a password-based authentication. So what I want to accomplish is this piece of code, this segment, what it does. Let's copy it from here and take it back to our actual playbook, which is the user YAML playbook. What this segment does is, let's go read. So I'm going to place it right here in line number 40. That's where I want to place it. And let's see what it does. Line 40. It says disallow password-based authentication. Line in file again. So that goes and changes some lines in some file somewhere. Where? This file. Oh, say that same file again, it seems. So SSHD daemon, SSH folder, SSHD daemon configuration. In that same file, we want to make sure that there is a line that says password authentication, no. And then restart SSH again. So we want to enable this scenario now. So we will first of all go to the box with our Cloud Genius user because we know we can get in, and then go to that HC SSHD, and there we open SSHD config, and you will find what you expect. Is password authentication? Yes, that's what you expect to begin with. Password authentication. And it says password, it is actually hidden out. So the password authentication is actually commented out. So there is a line like that. It says password authentication, yes, but that line is commented out. To change to no, to disable tunneled clear text passwords. That's what we want to actually accomplish. We want to make this line into a no and remove the comment hashtag. That's what I want to actually accomplish, but I will not do this by hand. Instead, I will call my Ansible playbook and you please do it. So it does. It goes to that machine, looks at that particular file, and we were not allowed to log in as a root user. Just right now, the playbook failed. The playbook failed for a valid reason. You look at this file and tell me the reason why it failed. If you look at that file, you will find that this playbook expects the Ansible user root, which doesn't even have privileges to log in anymore. So the Ansible play fails right there. Unreachable, message failed to connect to the host, permission denied, and that's why it was unable to finish the play. So the way to fix this, the way it rightly played, there's nothing broken here. This is how it should fail, because we have in a previous step disabled root user. So the only user that can now connect to this box is the Cloud Genius user. So I have to put that name right in there. Hey, you act the play in Ansible using the Cloud Genius user, not the root user, but use the Cloud Genius user going forward. That we have to make that change. And we did that change, which is what you are looking at right now. I made that change in the host file right there, and then save it and close it. And now I'm able to run this play again correctly, because this time when I play the play, it should play using the Cloud Genius user. And it succeeds. Yes. And so it disallowed SSH password authentication, Ansible example, and restarted SSH correctly. And so those two changes happened. Now, as a consequence of this, what you will notice is even Cloud Genius user cannot connect to the box using password 123. So we know our password is 123. So if you remove the public private key reference and also remove the SSH add, that actually remembers the key to begin with. So I'll remove all the keys there. And that removes any memory of a key pair stored that you want to periodically use going forward. And then remove this explicit key reference like that, and attempt to connect as Cloud Genius user to that IP address and see what happens. It connected. It should not connect because I did not give you a private key, man. But it still took the private key without. Where are you caching it? I removed your identity. Somewhere it is caching my private key. Where is that? And it's letting me in. Okay, let's try the same thing with the root user. Root user should be prevented, by the way. So if you attempt to connect SSH root at the same IP address, somewhere it is caching my private key and I have to figure out where it did. Root, attempt to connect to the root, and it straight away says permission denied. You're not allowed. You can see that right there. Permission denied public key, even though we have our private key, and we can even explicitly give it our private key. Here we go. Take my private key, please. -I, and here is my private key. ID_RSA. It still denies permission, because that's what we have done in our playbook, is to explicitly deny this cloud root user completely out of the box, and the Cloud Genius user still allowed. And I want to prevent the password-based authentication, which I also have. I have to figure out where my keys are getting cached. So even if I don't pass my key, it still connects because it is taking the key that I've implied and using them against my target box and letting me in. On a new box, it should not happen. On a new workstation, it should not happen. Now let's keep forward. There are a couple more things that you will see from a security standpoint. You have to make sure that you need to do as we go along. Is we disable password-based authentication for anybody, including the Cloud Genius user. Now we have to also disable API authentication, GSS API authentication, which is something that you can harden even if people are not using that. If people are not using that API, you want to make sure that you disable that. So that segment of code here, if you grab this piece, basically, and put that back in our user YAML and place this somewhere in, say, line number 50, and now you have the complete playbook at play with the Cloud Genius user in our target machine as we go along. So we'll run that Ansible play one more time. And this should completely execute the entire playbook as it was expected to. Are we in the right machine? We are on the cloud machine right now. So I will exit. Now we are on the workstation, and we will run the Ansible play one more time. It will disable GSS API access as well, and then report back success. So you can basically use this kind of a structure to construct segments, play-by-play segments of things that you want to accomplish, like play here, to play, add a user, to add that user to super users, to add a public key for that user, to disallow root access on the box, to disallow password-based access on the box, to disallow SSH GSS API authentication on that box. These actions you can keep expanding as your needs grow, as you may want to have, build an inventory of how you want to run how you want to accomplish a specific outcome or a series of specific outcomes against a series of boxes. So here are the boxes. I just have only one. You can run the same exercise on hundreds of boxes listed out in this file and apply the play against all those boxes in one shot with this finalized user YAML, playing against hundreds of hosts, thousands of hosts maybe. That will ensure that all of your boxes across your cloud are prevented from accessing as the root user. And you can tweak these elements in a machine as you go along, depending on what your needs are from a security standpoint. You can basically block out everything, every single thing, shut down all the ports except those that are needed, and enable only those users that need to get in, and be minimalistic in terms of applying any software that you want to have on that box and nothing else. And that's how you begin thinking about creating your foundation for a platform. And that was the example that we were trying the other day, and we ran out of time. So we finished this today. Now what I will do is go take our next example. In that next example, let's see, what do we have? By the way, before I jump forward, if there are any questions at this stage, please bring them in. I'm going to delete my machine here and prepare another one for the next exercise. So that machine goes away. And I'm going to review this hardening example, I think, which I already did. There's one more example that I wanted to cover with you. And that is this example. And this example I have, by the way, as you can notice, the Ansible related segments in the DevOps portion are fairly new. In so much so that they haven't been written down properly. All I have is just GitHub references where I am basically building out, writing those things in form of exercises or steps that people will do eventually. But these things are fairly new in the bootcamp. The exercises are there, they run. I see certain issues occasionally with Python 3. You saw them, me running into them. So that happens occasionally. But I will, find a way to write these things down, and you will eventually see that I will have things written down in form of steps Just like we have for Chef, you will see them also for Ansible coming up. I will evolve and write these things down specifically, and you can see them. I might change it sometime whenever I'm able to find time. I'll write these things down so that they are readable, not just a link to a Git repo that I have, like for example this. And so this is a GitHub repo that I will be using next in the next exercise I will be doing, which is what that action is. So that's what I will do. I will grab this and help you understand what it does, how it helps us, and what does it mean, and we'll do that as our next step. Questions are welcome anytime. If any of you have succeeded in playing out the security and hardening of a box to begin with from a user's perspective, let me know that you did. I just want to know. If you have it, let me know. In the meanwhile, I'm grabbing this particular cookbook that I have, it's called playbook. I still use the word cookbook. I should not. I'll grab that playbook in our workstation in here, and I will open it up in the terminal in another folder. So that folder, I think I already have downloaded. Yeah, it is that folder. That's folder, but I think it's what I want to do is just remove it and then clone it again. So I'll just remove that folder. I'm going to do a git clone on that Git repository. So it's coming down. We have it here called Docker Ansible. And that repository is where I will go inside and open it up in Atom and then help you understand what this thing does. So that Atom is open on the other window here. I will close out on this Atom so not to confuse anybody, and close out from here as well, and stick to the Atom window on the right half of the screen, which I just cloned. So that's what I have. And if I would like to now describe a couple more Ansible concepts here, which is this idea of Ansible configuration that you probably already have, we discussed this briefly. What I want to discuss next in terms of a concept is that like we have this idea of, hold on, let me discuss this in a OneNote. So if you remember from Chef usage perspective, if you go back to our Chef exercise, or rather discussion that we had on Chef, we used to have a thing called supermarket, right? So supermarket was a place where people will collect and put together their cookbooks. And they will have all these books ready for other people to use in the supermarket. Pretty similar in concept is this Ansible idea of Ansible Galaxy, where people will put ready to use Ansible code. And the thing that people put here in the Galaxy is called a role or a collection of roles. That's the nomenclature that you will find in the Ansible Galaxy. So people who know better than other people in terms of creating and using Ansible roles will create these roles and put them in the Galaxy. And we will go look at the Galaxy right now, see where it is. So if you'll say Ansible Galaxy, and it is right here, galaxy.ansible.com. You will also find that you need not log in. I think Ansible works without having to log in. So you don't have to log in onto GitHub, but you can just explore or browse roles or browse authors. So various people who author these roles, you can browse them by name if you like. Similarly, You can browse roles that you may be interested in. So here are a collection of variety of roles already available for us to accomplish. For example, this one is a MySQL role for Ansible. So you can put this Benno Joy MySQL role in your repository and use it like this, if you like. What I want to do is to go look for a ready-made role that is written for us to convert a machine that we get from these guys, or these cloud companies. They give us machines. They give us virtual machines or sometimes real machines from other companies, real hardware in the cloud. For example, here is one, Packet.net. They give you a real physical machine on the cloud on demand. That is bare metal cloud. And so you've seen them. There are more such clouds like Scaleway.com. Scaleway. So this cloud is based in Scaleway cloud is based in Amsterdam and Paris. So they give you also bare metal SSD. You can buy, or rather look at the pricing of SSD based bare metal clouds, and they're pretty cheap. If you want to get bare metal machines directly in the cloud, these guys are probably the cheapest cloud you can find. And that is what we will use in a subsequent exercise. And I don't have a coupon to give you, so you might want to stick to DigitalOcean where you have a coupon, or use this where you have unlimited, no, not unlimited, but 1 year free services. So you use Google Cloud, which gives you $300 of usage, which is quite a bit of money. So use any of the clouds you like as we go along. But what I'm really going to accomplish is this idea that I want to describe to you is what I really want to, hold on, let me get to the right spot. Yes, this is the right machine. So what I want to be able to accomplish is that as we yes, no, where was I writing? I think I have two OneNotes open apparently. That's what it looks like. Yeah, this OneNote is not the right one. This one is. Yes. So what I was talking about is this idea of putting together and using a ready-made role. So we went to the Galaxy to find out what is that place is, or how it looks like, and we want to expand on using other people's ready-made Ansible code to begin with. We will write our own roles also as we go along. But what I want to use is a ready-made role here from the Galaxy that helps us construct and convert a machine that we get into a place to run containers. And that's what I want to evolve. I think we have done some basic exercises with Docker already. And so, am I right? I think so. I think in the cloud technologies segment, I think we did some Docker exercises, I suspect.
Nothing I recall, so it must have been.
That is okay. Sorry. Yeah, I understand. So I'll find a way to help you out, Chris. That was Chris speaking, I guess. So yes, we have done some Docker exercises already, and what I want to essentially accomplish is we get an arbitrary machine from some arbitrary cloud and convert that to make it usable as a place to run containers, Docker containers to be specific. That transition I want to enable. Today, we get a machine, then we get the machine. I mean, then we can run some apps here. But instead of running apps directly on the machine, I would rather run it inside a container. So I have some machine, but I would rather convert this into a Docker platform. And then I will run my applications here in a container. And that makes it a lot more transportable. I can forklift this container, move it to another machine right here, which also happens to run Docker. So as long as it runs inside Docker, and you can take a container that runs some applications and you can transport it over fairly easily. And this transportability from one location to the other, or one machine to another machine, or on one cloud to another cloud, the transportation becomes really, really effortless. So that's how I prefer to run applications in the context of cloud, is within Docker containers. That's what I would like to accomplish, is I want to have a role here from the Galaxy that converts an arbitrary machine that I have into a place to run containers. That's what I really, really want. And that is what that next exercise is. So we have an exercise coming up, which we have just cloned in our this location. So this particular Docker Ansible playbook already does exactly what I just described to you. But how does it do that? That's what I want to explore. And so here we have our Ansible configuration defined. We are saying our host file is going to be a file called hosts that is underneath a folder called inventory, which is basically this folder right here. So in the inventory folder, I have a file called hosts that contains all the hosts that I currently manage. And so that file currently contains probably one entry, maybe two entries. One of them is commented out. And this is one entry, line number 4, only one. In that entry, you will find that it is not that complex. Let's go see what it contains. It contains a name or DNS name for a machine. It contains Ansible SSH host IP address, username root, Ansible private key reference to the private key that we intend to use, and that's it. Similar to this is another example where the Ansible SSH user is not root, but Ubuntu in the other cloud called Amazon Cloud. It is not root, but we get Ubuntu access. So that's how different clouds do different things. And in our example, what we want to use is any cloud that we like. So we have two flavors written down in the host file. We'll use one of them to begin with and expand to cover more. But that's our host file. That is defined in our Ansible configuration, which is line number 2. Inventory/hosts. That location is where I keep my list of computers I want to deal with. That is my host file. That's in Ansible CFG line number 2. Then the line number 3 has a specific thing here, which is called roles path. That is the place where I want to keep my Galaxy roles. And let's go see what these Galaxy roles are. And so I'll go to my Galaxy, and in the Ansible Galaxy right here, I find the role that I want to use is Docker Ubuntu. And the one that I like, I should search by name. I think it's called Docker Ubuntu. Which one is that? I think I have the name already in my folder right there. I'll go and look it up. So the role I want to use is this one. It's called, that name is the name of the author, Docker_Ubuntu. That's what I want to actually search for. So this is a role that I like. I have played with it before, and I want to search it by that name in our Galaxy. And so looks like the search function in Galaxy is kind of broken. But I want to see that particular. No, it doesn't want to show me. So what I'll do is go to Google, and there I will find it. I should find in Google. So I'll go to google.com, and then come on, open Google, please. And in Google, where I am feeling really lucky, I would like you to show me this thing called Docker Ubuntu by this gentleman, Angst Ward. That's the name that's the particular role I like to use. So that should pop up and it should take me to this location. So it's a convoluted way of searching, unfortunately, but this is the Galaxy entry written by this gentleman. And he created, Paul is his name. He goes by the name Angstward. He apparently loves Python. And given that he loves Python, he plays with Ansible, and he has created this particular role. And what this role does, as you can read, it's a comprehensive and ideally a sane way to install Docker on Ubuntu. That's what this role does. So I have played with it. I like it. And I'm going to use it. How do you use it? You go and use it like this. What does that do? So let's go figure it out. So we'll go to our workstation. In there, we have to go pull that role down from the Galaxy. So that role has to come down. The role currently doesn't exist in our machine right here. We know that our roles belong in that folder called line number 3. Roles path, a folder called roles. That's where roles belong, but the folder called roles doesn't even exist. So we need to create that folder, but if you run this command, it will automatically create that roles folder for us, and also goes to the Ansible Galaxy and brings down that particular role for us. That's what I want to do. So I will run this line number 7 as is in our command line, right in that location, and say, please go get me that thing. The thing is angstward.docker_ubuntu. And what that thing does is goes to that Galaxy and brings it down, puts it right there in the roles folder. And that folder contains angstward docker. It's a fairly complex set of things in there, which is a way to write a role in Ansible. So we'll go through that in detail. But right now, I want to just get to some outcome, like I want to accomplish something. So I will like to run this play on some random machine out there, some random machine, right? So I'll get some random machine to, some random location, say this cloud. No, this is not a cloud. Yeah, this cloud. So get me a random machine. So here we go. Deploy a new machine in Seattle. And I would like you to become my host for Docker. So you know what? Yeah, that's a good version. And I would like to get some good amount of RAM here. So 2 GB RAM is a good one. You don't need it, by the way. You can go with the cheapest one. No problem. But since I want to run some applications that are in need of more memory, I might want to use a bigger box or even bigger box. But that is going to be overkill for my application. So maybe sticking here and just using 2 GB memory is good enough. With that, I will also provide my key and give it a name. I'll call this my Docker host, because that's where I want to run my Docker containers in that box, inside this box that I'm creating right now. So that new instance, Seattle location, Ubuntu server, 14, this 2048 memory. And in that box, use my private key and call it Docker host. So this is where I will have a new machine running Docker for my application, running and up and all that good stuff. That's what I want to accomplish. So I'll just deploy the box. I get a box now, soon. I'll get an IP address here. I'll use that IP address and take it to my workstation. And in there, I need to make sure that my host file actually is correct. So that this host file needs to be correct so that it can connect and install and prepare my machine to become a Docker host. So that IP address needs to change. So I'll delete that, save it, and wait for the IP address to pop up. So the IP address should already be available by now. If I refresh, I should get an IP address. And there it is. So I grab that IP address. I'll say, give me my IP address. There we go. So I copy it and then go to my VM and paste it in the right location right there. So now I have my IP address in place. Good to know. Now, once that is done, what I want to be able to do is remember that this first line number 1 is a commented line. It has a hashtag at the beginning. So don't worry about it. It's comment. Line number 4 is the only operative line. This machine is not in DigitalOcean. It is in Vulture Cloud. But again, these names do not matter. So I'm just calling it vulture.cloudgenie.us or just vulture for short. What matters is the IP address has to be correct. Now I'm going to run this play on the vulture box. So I'll copy that and make sure that I run this Docker YAML, this role that I have, on the target box. What is the target box? That box is all the hosts that I have in my host file. Where is my host file? This file. How many hosts I have? 1. All of them. 1. And it will run that play. The role will play on all the hosts that I have. And just to confuse you further with Ansible, sometimes Ansible uses the word become for sudo. And that's a change that's happening. So sometimes they'll use the word sudo. Sometimes they'll use the word become. Become basically means become a super user. That's how I think about it. That's, I think, the meaning behind it. Become a super user. Similar to the word sudo that you know already from the past examples. And in this Docker YAML play, it's fairly short. If you look at it, just 9 lines. 9 lines of this code will convert all the boxes you have in the host file into a Docker host. How does it do that magically? It does that because of this gentleman, Paul, who goes by the name Angstward, and he has created a role for us called Docker Ubuntu. That role is given to us in that folder, and you can see it in great detail, which we'll look at it later. But right now, I want to make sure that all these machines convert into a Docker host. So first thing first, I want to connect to that machine and find out if it already has Docker. So I'll go to that box right there and say copy, save and close, and connect to it and say, hey, do I have Docker? And so I get connected, and then I'll say Docker PS. Do I have Docker? No, it is not installed. Fine. I know it's not installed. Great. But I want to run it. I want to run my play. How do I run my play? I run the Docker play by going like Ansible playbook, run my Docker YAML play. The Docker YAML play is very simple, very short. It applies to all the hosts that I have in my host file. My host file is only containing 1 host right now. It will apply to all the hosts, by the way. And become equal to yes means it will become a super user. And so we have to make sure that we allow that. If it asks for a password, we have to give that a password. But since this is a root user and it's created with the SSH based key, that password prompt is not necessary. And then line number 6 describes a role. The role is what will do the magic to make sure that this collection of boxes that we have defined in the hosts file, all of them become Docker hosts. That's what we want to accomplish. We can accomplish that simply by running this particular play. And after that play runs, this role runs, you will make sure that the kernel package state is present. This basically the required kernel that is required to run Docker is included and is present. That will make sure that it happens. Then Docker creates a user called Docker and a group called Docker. And so you want to make sure that the person who's logging into those boxes also become Docker group members. So that's what we want to pass. And if you don't pass anything, it will take the correctly logged in user and make them a Docker member group. And that is what we'll expect to run in this example. We'll just run our play, which is basically this line here, Ansible playbook, run the Docker YAML play. That play will use this playbook and convert all the boxes into Docker hosts. So let's go play. It will go connect to all the boxes you have and it fails. It says Python not found. This was known. And so the way to resolve this is this line. You have to pass that parameter in our host file right there. Python 3 not found. I mean, Python 2 not found. Of course, you don't have Python. I know that. And so that can be passed by placing this extra argument to make it use the Ansible Python 3 interpreter. And once these things stabilize, I think we will evolve Ansible in a full-fledged program curriculum in our DevOps section. Right now, it is still, I find it is still evolving. And so we occasionally run into issues as we go along. So I will add that line that says to use Python 3 interpreter, please, for this version of Ubuntu doesn't have Python 2. It should already know that you don't have Python 2 and fix it by itself instead of asking me to go and add that line there. But that's what happens in new open source software. So back here again, we'll say, please try again. And it failed. It says, wow, it hurts. And so it fails, saying, fail if using Python 3 with Ansible 2.3. So it is failing by design. This guy knows that, it doesn't work with Python 3. So Ansible 2.3 is required to use Python 3 interpreter. So either you update your either you update Ansible itself, which I think we are using a slightly older version of Ansible, not 2.3, it seems. Ansible version. Our Ansible version is 2.2. And the version that this guy says that we should have is 2.3. So we can give it a shot. And so I'd like to read that error one more time. I'm running it again to get the error. The error is Ansible 2.3 is required to use Python 3 interpreter. Okay. So we can attempt to update to Ansible latest 2.3 if we can. Right now we have 2.2.1. So I'll do that live. But again, these are live updates, so it might fail. And we know that it might fail. So having understood that piece, I'll check my Ansible and see if I can update it live to the latest version. Okay. Yes, I think we can update. Pip install. Let's see if it updates Ansible to 2.3. Looks like it is updating right now. And so I'm updating Ansible version installed in this box to Ansible version 2.3 as we speak on the fly, in the hopes that this will work. Otherwise, the only way to resort this is back down to version 14.04, where things work out okay. I mean, there's no issue. The moment you start using newer versions of Ubuntu, you run into these issues when we run into an install issue because of permission denied, which means we have to run it like this, sudo. Oh, we have to give it an H flag. It says give an H flag. It says give an H flag. Where does it say? I saw that. It seems to have succeeded, but I want to repeat that with an H flag. That was the complaint it had. executing pip with sudo, you may want to use sudo's -h flag. Okay, I will use that. So here is your h flag. Please sudo -h. Okay, so now our Ansible version is 2.3. Come on, show me. Ansible version is 2.3. Yes. And okay, good. So now let us run that play one more time and see what the new failure is. And it seems to be going okay, at least up to now. So no failures. So let's go watch it and see what happens at the end. We will expect to convert our box that we have with this cloud that gave us that box become a Docker host. And then we'll play Docker in that box. That's how I would like to use this tooling primarily, is to get to a point where we can quickly get to the result, which is to use containers with our cloud services. So it is doing those things, and I'm happy to see that up until now we don't have an error, which is a good thing. But that's what you have. With cutting edge open source, you occasionally run into those issues. So let's go see, when was this github.com/Ansible 2.3, when did it come out? So Ansible 2.3 should be fairly new. Ansible version 2.3 was updated. Tag 2.3, please. And that is this tag. Was updated what? When? April 12th. Okay. New release April 12th, a month ago. So it's fairly new. Our virtual machine is February, so it is slightly old. And this is a month ago, meaning month of April, 12th of April. As you can see, the 12th of April was the last commit for this particular version, 2300, which is what we have running in that VM. In this VM, we have that 2300 running, and we have a failure. The failure username is undefined. I think this issue is probably because of a host variable that we haven't actually defined a username that we have to do for every host. So that entry we have to create, and this is something that I find that we have to create. As I can read the error, it basically is telling me that for every host that has a user, you need to call it out by name. So I'm going to rename this vulture. This file should be renamed as vultr. And when I do that, it gets the username defined and a home location defined for that particular name, vulture.yaml. That's what I just accomplished. And that way we are basically declaring that user reference of username, which is the last step in that Docker playbook here, is to add Docker group members for the username user. And the username user is, in our example, root. So that membership addition part did not succeed because this file did not exist for that host called vulture. So we now have that, which means we should just run the play one more time, and this last step should also succeed. Doing that right now. It should finish off very quickly because all the things are already done. Only the very last thing of adding that user to the Docker group should succeed in this attempt, because it is able to find that particular user as declared in the host variables in this file right here called host variables in the inventory. So sometimes some users have a different host name, username. Some others have different names. In our example, the host called vulture had a username called root. So the username variable in the host variables file should be called out as root, for example. We have done that here in this file. The host username is root. For Amazon example, the host username is Ubuntu. So we have done that already, but we changed our host name from DigitalOcean to Vulture, and we did not have a vulture.yaml file in there. That was the reason why it did not pick up the default name by itself. And I think we have success, but let's go check. And yes, it shows that our users were added to the Docker group. That item also succeeded with items equal root. That we have success. And now we should connect, and we have our works that machine in the Vulture Cloud configured as a Docker host. So we had to do a couple of things. For example, we had to update our Ansible version to 2.3 for it to actually work with version 3 of Python. Then we are also going to check and remotely connect to that machine, which is this box, where we should now have Docker. And if I run Docker right here, it should tell me, yes, they have Docker in there. So we have Docker host ready for us to play with Docker. And that's what we just did in multiple steps. So we had lots of moving parts in there. And a couple of moving parts that I want to write them down for you is to make sure that we understand is that we were playing with later versions of Ubuntu. So for example, here, if you, not here, for example, in this cloud called Vulture, come on, this cloud, if you get a box that has a, let's go to Seattle and say, give me a box running Ubuntu version 14.04, that one. And in there, I would like to have the public key loaded, and this is Docker host. That's the name I want to choose. And I will say, get me a machine. So I'm getting a slightly older version of Ubuntu right there. And it will also become a Docker host, by the way. So that's what this particular play written by this gentleman in the Ansible Galaxy. The gentleman's name is not this. Hold on, where did I go? Yeah, this gentleman. Angstward is his name, but his real name is Paul. So that's what this gentleman has done. He has created this role, which is fairly popular. People use it. 322 people have given it a star. And that is the actual role that you can see and go in detail, and he keeps it up to date. And that's basically enables the scenario of you getting any machine, including this version of Ubuntu, which is a slightly older version. You can take that, copy this new IP address, go back to our workstation, and in there, what I want to be able to do is, in our host listing, I'm going to call it out that this machine is slightly different, and it does not contain Python 3. It uses Python 2. So it is slightly different. So in that, its name is also different. Its name is Vulture 1. And it has a different IP address, which is this IP address. So I'll take that IP address, put that in that location. And then the Ansible Python interpreter line is unnecessary because it doesn't use Python 3, it uses Python 2 already. It is an older OS. And so we have a new line item there called Vulture 1, which requires a declaration of this type to declare host variable names, the location of home location of the user, and its username, whatever that you may have for that host. So in our example, the host name is Vulture 1. So we have to go create a new file in here that looks like this, but contains the same content, but saves the name in your user Docker Ansible inventory host variables. That name should be Vulture 1. That matches your name description in the host file, just like that. So this name will match this YAML and automatically pick up the username root as it goes along. So we'll play the same play again. Now it will play the same play on 2 different roles. And you can see that happen as we go. We'll go back to our virtual machine and put this atom editor on 1/2 of the screen, like that. And run the same play again one more time. So Ansible play, Docker. It'll take those 2 boxes, convert both of them into a Docker host. One of them is a slightly older version of OS. It uses Python 2. Vulture uses Python 3. Vulture 1 uses Python 2. And you see that it is actually applying the same play of that role on 2 boxes simultaneously. You can see there's things differently called out like this. So skipping particular action. If it's not necessary, it will skip those actions. You can see that further, it is installing this extra driver needed to enable AUFS. This is the file system needed for Docker to run, if you recall the discussion of a layered file system. So that's what is happening right there, is installing layered file system on that new box that we have. It is skipping Vulture. It is doing that installation on Vulture 1 because it needed that piece. This Vulture 1, it needed that particular AUFS driver. So it gets the driver for that box. This Vulture machine doesn't need that, so it skips that. And that's how it goes on, finishing up all the things needed on both boxes that are missing. It will fix those. For example, here, add Docker repository. It was not necessary on the Vulture box, the first box we already set up. It was necessary on this box, which we just set up, or just are in the process of setting up. Same thing here, install and update Docker package. The other machine, Vulture, already had it. This machine does not, so it installs it. And same thing here as we go. It says Python 3 dev. And for this machine, which is the older version of OS, it says Python dev. So it already is picking up the correct version of Python as we go along. And at the end, it will report back success for both the boxes, except it tells you that I changed nothing in the Vulture box. And I changed 9 things in the Vulture 1 box. So nothing actually changed in the Vulture box. If you repeat the play one more time, it'll go very fast and it'll tell you nothing changed. Totally expected. That's how it goes. That's what you're seeing. And that the result would be nothing changed. So at the end of this, we will have two Docker hosts running in our cloud. So let's recap what we did, and we'll take a short break and continue. So I'm going to recap right now. Here is what we did, and we first of all grabbed a machine here. This was a Ubuntu 16.04 machine, so it's newer version of OS. It has Python 3 there, and we began playing our role. This role that we wanted to play was this gentleman Angstward. I'm sorry for butchering his name, but he has given us this Docker role that we want to play on a target machine like this. So we started playing, and we had our Ansible version 2.2. And we attempted to play, and then we said, you know what, Python 3. So we use a flag here in the host file that tells this machine that it is indeed Python 3. Then this complained back saying, you know what, this version doesn't work. You update it to Ansible 2.3. You can also update, by the way, and I will give you specific steps on how to update Ansible on your boxes. It goes like this. If you run this, it will upgrade Ansible on your machine from whatever it is currently 2.2 to the newest version available at that time, which is today 2.3. So that change will happen as we go along, as you update your Ansible, which you may need to do because that's what is a necessary thing we found out. That actually is a good sign that people are progressing Ansible in a direction to support Python 3, which is nice. So now that we have this working, we then ran the play again. And as a result, what we saw is that this box became a Docker host. So we can now run containers here. Then we took another box. This was version 14.04. It has Python 2. And so we run the same play and it ran fine. It said, yeah, you have Docker now, and this becomes a Docker host. So we'll go and check whether it actually does run Docker for us. So we'll go to that machine right now and validate whether that machine actually runs Docker. So the second machine that we have, which is this machine, is called this host. We have is this IP address number, this IP address. So I'll copy that IP address. And you can see that we ran this play again. It says I changed nothing on both boxes. It's all green, no changes. And that's what is expected. Hold on. So that's what is expected. I'm going to connect to that other box, which is SSH root at the second IP address we have. And there we get connected. This is your Ubuntu version 14.04. Let's see, /release should show you Ubuntu 14.04 right there. And that's an older version of Ubuntu. You can see that it has Docker running already. And so does the other machine, the newer version of Ubuntu. Both of them have Docker running already because, and with fairly simple way of getting it to run is because of this gentleman. And we should thank him for making it easy for us. Otherwise, it's quite a bit of effort if you think about it, as to what it takes to make sure that you can get any Ubuntu box, make it a Docker host with simple steps, as simple as running this short play. That's it. It's so succinct, 9 lines. Actually, most of them are comments. You basically, the operative line is right there, line number 7. You invoke the role, and that's all you need to do. The role will get invoked against a target, which is this host that you have in mind. And that target will basically run that role on all the targets that you call out here. The targets are called out here. And we have currently 2 machines. And we can similarly try another one in the Amazon cloud, if you will. So that's fairly easy. You can expand on your fleet of machines that you have running. And what we intend to do is let's understand how easy and simple it can become by going to, I'm going to play with my Oregon cloud and create a machine out there. And I will say, give me a Ubuntu machine. I think this is going to be also latest version of Ubuntu. So 16.04 is what you're likely to get. In this location, you will see that this machine is 16.04. So we select that and we'll say, give me a T2 micro, configure the instance. And here I would like to choose my default VPC, and I would like to get a public IP address. And I would like to proceed forward to add some storage, and that storage is good. So I add some tags, and I'll say this is my tag. I call it my Docker host. And then I configure my security groups. I use an existing group I have, which is the default security group, which is already open for port number 22, and I review and launch, and I'll say that I have my private key in good shape. I have that key pair with me, And so please launch the instance. It launches the instance. You can see that the launch instance gives you an IP address. And all we need to do is go back and put an entry in our host declaration. So that IP address we are going to get here in the public IP address soon. In that section, we'll receive a public IP pretty soon, and that becomes an entry in our host file in here. We have to go modify this line right there, uncomment the Amazon reference, use this IP address, delete that, and put the new IP address in the right spot. That's what I'm waiting for, the IP address, which is going to pop up any moment. As soon as it does, I'll grab it. Come on, show me the IP address, please. And there it is. So we have an IP address right there. I'm going to copy it and go back to our workstation in there and paste the IP address and then save and close. And by the way, you should cross-examine that this file amazon.cloudgenie.us has a username called Ubuntu, and the home location is not /root but /home/Ubuntu. That's the location difference and the user difference in what Amazon does with other clouds. So now we have these 3 lines, 3 machines, all of them becoming a host for Docker for us. We'll go and test and validate. So first thing first, SSH Ubuntu at IP address. Can I connect to this box, please? Can I connect to that box? So I'll grab the IP address, this one, copy it, and then paste it, and I connect successfully. Nice, I exit. Once I test my connection, I can proceed to run my play one more time. But before I do that, there is a problem. The problem is we have to make sure that this Python 3 reference is included, which currently does not include. So we have to expand this line to include this segment, which is to use the Python interpreter for Ubuntu, Python interpreter for Python 3. So that line, we have to copy that line and put that in the Amazon's segment up on top and paste it right there. So now we have 2 lines, first and second, both using Python 3 interpreter, and line number 3 does not. So we save it, and now it should work in here. And we run the play. It should do nothing on the second and third boxes. And on the Amazon box, it will go to do its thing, and you will get the result that you expect. And we'll have 3 Docker hosts ready for our infrastructure, ready to take our applications, our scenarios for us to run. And then after this finishes, I will take a short break and play with our Docker hosts and put some applications on top, and you will see how delightfully simple it is. Once Docker gets to run, life is simple. You've seen that before. We'll see it more. We'll see more of it. It is doing it, by the way. Seems to be. So succeeded. It did. And we'll go validate that. We'll go again to that machine, the newly constructed Amazon machine, and say, can I please connect to you? And it lets me connect. Now, can you please tell me if you have Docker running? And it says, yes, I do. Nice. Nice. So now let's start a break. I will pause. So I start the timer and discuss the next steps after we resume from break. So here goes the timer. Timer 7 minutes. And off it goes. Come on, run the timer. There it goes. So timer is running, and I will see you shortly. Hey guys, are you back? Hello.
Yep.
Yep.
Okay, good. I was just checking. So before we change subjects and change topics, I just want to understand any questions if you have, or if you any ideas, any thoughts on what we just did, because it is different. It is different from what we had in done with Chef, with a fairly elaborate exercise. Whereas in case of Ansible, the examples that I'm really trying to drive towards is get to a point where we can convert an existing infrastructure into a shape which will run an application inside a container. That's what we really want to accomplish. And that is what I intend to do. So I will, at any time let you know that you have a question, you just ask it. But what I want to do now is the machines that we have there in 3 different clouds. We'll just pick one at random and convert that to run some real application. That's what I want to do. So I'll grab some example applications that are ready-made in Docker and use that application in the context of our Docker infrastructure. We have 3 Docker hosts ready right now. And I want to run, select one of them and run WordPress on top. That's my goal. My short-term immediate goal is I would like to get WordPress running, like all of it right now. So give it to me. So I know of a ready-made Docker solution that runs WordPress, and it is purely used as an example. This is not a production usage example. Purely for academic purposes is what I suggest. Begin playing with this particular method of running WordPress inside a container in a Docker host. It is giving us out of the box Docker image ready with WordPress. So it is fairly simple to use to get us to wrap our head around the idea. And that's what we intend to do. So just taking the example application WordPress, putting that in a container and taking that container to run on one of these boxes that we have. So we have like 2 boxes here. One of them is called Docker host and the other one is called whatever it's called. Yeah, this is Docker host. I just randomly named them, these 2 names. And I want to choose one of these guys and run this image. This concept of an image, specifically for our friend Christopher, who is probably new to this idea of Docker, is something that I would like to quickly recap. So that recap goes like this. In Docker, we have a library, a place where people will put images. And that location is called Docker Hub. Oh, not Bub, but Hub. Okay, delete that. Hub.docker.com. That's where the images are stored. Anybody can put an image there. And you can take that image down by loading it on a Docker host and run it. You bring it down and then you run it. When you run it, it becomes a container. When you have it here, it is an image. What we are going to use right now is a ready-made image from this person, Tutum. Actually, it's not a person. It used to be a name of a company, .tutum.co, that got acquired by Docker. It used to be an Turkish company. This Tutum is a Turkish name. It means attitude. And so that's what Turkish company Tutum got acquired by. I don't even know if it's a Turkish company. It had Turkish people there though. So that Tutum name came from them. And this is now a part of the Docker company. So that's where this image is originally from, is this Tutum company, which created this image about a year ago. And that image is available in this location known as Docker Hub. This, we are looking at the Docker Hub. To pull that image down to a machine where you want to run it, you go like this. You pull it, basically, literally Docker pull. So I'm going to pull it. Pull where? On one of these boxes. Which one? I'll pick this box. So I'll just pick that box and say, you know what, I want to use you right now. And in that box, what I want to do is, come on, let me copy this. No, it would not let me copy, huh? Okay, copy please. Yeah, nice. Okay, I'm going to copy you and connect to that box. So right now here, I am going to connect to SSH root at IP address, and I connected. In that box, I have Docker running. I can see that it is there. And in that machine, I want to pull this image down. Pull it down, as in Docker pull. Right now, if I say Docker images, how many images do I have? It tells me I have nothing. True, nothing. To begin with, I have nothing. But I want to grab this image. Which one? Where is that? Here. This image I want to grab. So I'll say Docker pull tutum WordPress. So I copy that command. Copy it. And then back to my host in the cloud. What I want to do is pull it down to this location. So I'll say Docker pull. The image comes from the Docker Hub library and sits on the Docker host. This is the Docker host, which is a machine that I have configured to run Docker using Ansible. So that machine image is getting deposited on, or rather I should say pulled down on the Docker host right now. The pull is complete. As a consequence of this pull, we have Docker images showing us that we have one image ready. We can see that it tells us that the size of the image is 477 MB. It has an image ID. Its name is tutum WordPress. Now, as simple as getting this image to run, we can see that this particular tutum WordPress image is actually fairly simple to run. Running involves this command. That's it. So when we run this command, we will have a running, fully functional WordPress ready, up and running like magic. Now just compare and contrast with the amount of work that you had to go do in your chef exercise. This is fairly ridiculously simple. So I'll just paste that run. No, not this. I'll just run it like it describes. I have to go and copy that. This is the command I want to run. So I'll describe the command also to you, just a minute. But first, I want to get to run it. So that's what I'm doing, is getting to my workstation. And I have already pulled the image. I want to now run it. So this method of running involves some parameters that I will describe to you. What does this mean? But essentially, apart from these things, it is Docker run followed by image name. That's it. That's all it has. So we'll just run it first. Here we go. And it runs. And it is running right now. It is perpetually running. This perpetual business of running something comes from this D factor. -D it runs it like a demon, runs it all the time. That's why it exits nicely and cleanly, giving you this hash ID. That is the ID of the container that it started. And that container now runs in Docker like a demon. This -P reference is a port mapping between the container and the actual machine, the Docker host machine. Port number 80 is mapped to the port number 80 from the container to the host, which means if you go visit this IP address for this box, which you can find here, which is how we connected ifconfig, which is this IP address. you should see WordPress right there waiting for you. As simple as that. And we open it up in a browser window, and what do you see? Boom, WordPress. Continue. And you can just provide your title and your username and password and say, I know it is weak, and an email address, and install, and you're done. And there it is. So we have a fully functional WordPress site on our own Docker host running on our infrastructure. And that's what you got. And you have your WordPress site up and running. There we go. So now this may sound magical, but we need to understand how do you get to this point. So there's no magic in here, absolutely none. The way we accomplish this was actually, if you look at it from the top down perspective, it's simple. What did we do? We set up a machine, our workstation, to operate Ansible. And we used a role called Docker Ubuntu. This role we obtained from the Galaxy. And we basically invoked this role. We chose to invoke this role on a target machine. This target machine that we used, we called it the Docker host machine. This machine, where did we get from? We got it from a cloud that gave us a box running 16.04 version of Ubuntu. And we had this Python 3 problem. We fixed that by updating Ansible to 2.3 and calling out the Ansible Python interpreter Python 3 in the host reference. And once that happened, then we converted this machine, plain old Ubuntu machine, from this cloud into a Docker host. Now we have a Docker container running. And by the way, we did this thing on 2 other machines as well. So another and another. So that's a side issue. That's a side issue. Next, what we wanted to do is get this box to run WordPress. So what we did is went to the Docker hub, hub.docker.com, and looked for a repository that already contains WordPress image. And so we just pulled that image down, pull. And then we run the image, run. And we do a port mapping. And boom, we go, we get WordPress live at this IP address. That's what we did. But to build all this magic, that seems like magic, but it is not. There is a playbook involved here that runs the role. And similarly, there is a image construction process here that constructs the image called WordPress that somebody at Tutum did for us. At this company, somebody created this image for us and they gave it to everybody. They put that in the Docker hub. How do you construct an image? Exactly that image. How do you construct this image to run WordPress? That may sound complex, but let me tell you, it is not. We'll see how these guys built it, these Tutum guys. What we will do is go ask them, hey, how did you build the image? They will tell us. Typically, people will tell you how they build the image. If they don't tell you how they build the image, they do not belong in the open source community. Honestly, they don't belong. If they're trying to hide something as to how they build it or how they create something, I strongly recommend staying away from those people. Like if they don't tell you what is in their image, don't go touch it at all. It is like not worthy of touching. So this image, if they don't tell us how they build it, I should not use it. As simple as that. That's a thumb rule. In open source, if you are touching something, you need to know what is inside. You should examine what it contains. You should be able to build it yourself. You should also trust the person who constructed, like these guys, Tutum. And only then you use open source products. Otherwise, there is no point. Otherwise, it is not open. If you cannot inspect and examine what is inside, it is not open. And so don't touch it. So let's go ask them. So the owners, Tutum, should have a repository in GitHub that points to this location. It is a little bit old. Oh, there it is. So more information right there. For details on how to access the bundled MySQL server or specific passwords or this and that, visit the repository, click. So they'll tell you how they built it. And here it is. It says, okay, this is a change. It says this repo is deprecated. We are not going to maintain it anymore. You visit Docker store to explore similar images. To access the latest commit of code, please switch to master branch. Boom. So we switch to the master branch. And by the way, here, back in here, we should also go history and examine what it contains. So there's a deprecated branch. So you can scroll that back, go back to the repository on GitHub. And here you see that there is this branch called deprecated. If you scroll to the master branch, you should see the repository as it was to begin with that helps you construct that image that basically started that thing that we did. So how did they do it? That's what is written down here. The thing that does it is this one file called Docker file. That file does it. How does it do? It is written down right here. These are the steps that you will find familiar because you have done these things already. And that is what in a chef exercise, you have done these things, not exactly like this, but somewhat like this. You will find many, many pieces of here familiar to you already, given that you have done the chef exercise. What this does is puts together a sequence of steps to build an image known as the Docker image that we just used. And that image is constructed using steps defined in a Docker file. That is this file that was used to construct our, where did that go? Where did that go? So we had a WordPress running, right? Wherever that thing is that we apparently, I think I closed out on it. I can open it up again. But this IP address that you see here, which is running WordPress, as you can see in this location, it should show you WordPress, and that is right here. That WordPress, that instance of WordPress is actually running on this IP address here. And that is running because of this image that you brought down, you pulled down from the Docker Hub, and you ran that image like here. That image is constructed based on the Docker file given to us by these guys in this location. This is how they constructed that image. Let's go start reading it. You will find it easy to understand. It's a very short file. It's only 42 lines, but I will simplify it for you. So here, the first step that they do is begin with a known good starting point. That known good starting point is Ubuntu Trusty. That version of Ubuntu called Trusty is what they begin from. They give their names, the people who created that. These people belong to the Tutum company. And then they begin installing some packages needed to make WordPress run. You will find that they install supervisor, Git, Apache 2, libapache mod PHP 5, MySQL server, PHP 5 MySQL, pwgen, PHP APC, PHP 5 encrypt, and then they echo the server name localhost to this file. Basically, they want to run this on the localhost machine wherever this image runs. Then they configure and add some installation and configuration scripts that are already provided to in a different folder. You can see those other files. These files like start Apache script and a start MySQL script are written as independent files in the same folder level. They are right here. Start Apache and start MySQL are two different scripts that they have created, and they're using it in the Docker file right there. In here, you will find that they are copying that script into the root location, copying the MySQL script also in the root location. And then they want to also copy one more script to run the WordPress instance. They want to chmod the permission sets to 755 so that they become runnable by the root user. And they add some configuration for MySQL in that location. They're also adding supervisor daemon Apache 2 configuration in that location to enable supervisor control of Apache 2. Also, similarly, enabling supervisor control of MySQL. Removing some pre-installed databases if you have any. So that will basically destroy your databases if you have any already. Remove that to make it clean, make it fresh for a new image that gets up and running. You want to make room for it. So remove any pre-installed databases that you might have. Add MySQL utilities so that you can create an admin user and make sure that its permissions are 755. Enable HT access. So this is a slightly advanced Apache topic, but essentially it's a file called HT access that sits in this location. And you want to be able to have that file control access for Apache server and its configuration. And that's what this particular file will do. So you're adding this Apache default in that location becomes available. When you have a 000 default.conf available in the sites available folder, you're basically enabling the default Apache behavior. You're also enabling a module to rewrite the URLs in Apache. That is A2nmod rewrite Apache. You may recall this thing we did in Chef exercise a while ago. Then it clones a example application. This is in case you want to run an example LAMP application. But in the case of WordPress, what they have done, which is now deprecated, is that they actually clone the WordPress application. Instead of this LAMP application, they clone the WordPress application right there. And once that happens, you set some PHP upload maximum file size to 10, PHP post maximum size to 10 MB. You add some volumes for Docker to use with MySQL. So this is where MySQL will store the data, these two locations, expose these two ports, and run the run.sh. So what does that run.sh do? You go back here and read what run.sh does. You will see that it is also another script, which basically is going to create and execute supervisor D. What supervisor D will do in turn is run WordPress and run MySQL. So at the end of this result, when you have an image constructed using this Docker file that you are looking at right now, and we'll do more Docker file examples and then put them in a variety of containers as we go along. I think we have done a couple of them, but I want to show you a simple I wanted to show you a simple example of a complete application. That's what I just did in the context of running a full application right here in this IP address. We were able to do that fairly easily by using our approach, like I described here, is in simple steps. What we did was, give me a second, full screen. View, and view should be 100%. Why is the view broken? View. Why is the view broken? There it is. Now, okay. So in simple terms, we began with a machine, blank, empty machine running Ubuntu. We had our Ansible tooling that converted this Ubuntu machine into a Docker host. And then we went to the hub.docker.com, and from there pulled down an image that we want to run. This image that we wanted was the WordPress image. And we said, yeah, go run it now. So when we run it, this box that has become a Docker host was able to pull down a Docker image for WordPress, was able to run that image, becomes a WordPress box running an application for us. We are still here orchestrating whatever we want on whichever box we want, convert any arbitrary machine into a Docker host to run any application that we like, and get to a result fairly quickly. That's what we really accomplished. You can see how quickly we can actually do these things simply by looking at another example. So we have this host here that is fairly untouched. So we have nothing in there. So let's go to that host. And in there, we'll say, you know what, I want to connect to you. So SSH root at, and it connects. We have Docker PS running. This runs to WordPress. So maybe not that host. We'll come out of here. We'll go to the other host, which is not running anything. And that machine is this machine probably. So copy that and ask this machine, can you let me in? And it lets me in. I'll say, Docker, do you have it there running? Yes. Am I typing it wrong or what? I think I'm copying pasting wrong. Yeah, I copy pasted the same number again twice. Boo. So copy this number, please, not that number. Copy and get me this machine. Yeah, this machine is where I have. So in that box, I want to copy not this IP address. Sorry, not this IP address, but the other one. So SSH, give me another box. This box, connect to it. And here, I want to say, do you have Docker? Yes. Do you have any Docker images? No. Do you want me to pull a Docker image for you? I said, yes, go pull to WordPress, please. So it pulls it. And when the machine image gets pulled, I can run it fairly easily. And at the end, I should have another WordPress, fresh, simple, and up and running in a matter of minutes. As you can see, I should be able to get a WordPress running on this location. I can try to open it right now. And it will show me nothing because there is nothing right now. I have nothing running. So it should show you unable to connect, which is expected. Cannot reach this page. However, you will soon find that I have an image ready, which means I can go Docker images and see the image right there. I can then run Docker run, right, like a daemon, and give me a port mapping like this, and run that image that we have for you already. And so here you go, it runs. So I can now go back to my machine there and refresh, and I should see a fresh new WordPress right in the same spot coming up. If I refresh properly, there goes WordPress. So continue, and this is another WordPress. And we log in. And we should get success just like we did before. And here it is. This is another WordPress site. We were able to get to this very easily, very quickly, because of the idea of using ready-made images for Docker. And we were able to run it like this. Fair and simple. Now, let us see if we have more exercises for us to play with in our write-up. I think we do have a couple of them here. And using Docker. So I want to be able to demonstrate this idea of creating our own Docker file and building our own images and running our own images. That's what I will quickly demonstrate, and then move on to a slightly higher order construct of putting together what I call a Docker compose.yaml, but that's the name that Docker likes to use. We'll go through this example also. This is a ready to use example. But before we get to understanding what this thing does, I want to make sure that we get these things clear in our mind. And those things are, how do we build an image? How do we use Docker files specifically to construct an image? And how do you run an image? Running an image is fairly simple. You saw me in the Docker run and boom, it runs. Building an image is Docker build and it builds an image. That's it. Let me ask you this question. Did we do the Docker build an image Docker file exercise already, or is this new to you? Docker file and building an image, sharing an image among team members. And did we do that exercise already?
I want to say that's new. I don't remember it.
You do not remember. That was Chris speaking. Okay. So maybe I was confused okay. So what I want to do is help you understand how to build an image. And then how do you push that image to the Docker Hub? How do you then pull that image down is easy. Docker pull image name. Docker run image name. That's how you run. So running and building is easy. You saw me pull an image. You saw me run an image. Fairly easy. The other part is not that easy, but still easy. The easy part is to write down whatever you need in form of descriptive language in a file called Docker file. That's how you basically build an image. So we'll run live examples. Since you don't recall or remember, I will run live examples. So here we go. Live examples of something. First of all, I will define a new folder here. And in that folder, I will call it Chris Taylor. And in that folder, I want to create an image for an application that I will build with Chris. But for simplicity, I will build that image really, really simple. All I want to do is have a site that says, hello. That's it. Now, that's the outcome I want. All it should read is hello. On a web page, when it opens the HTTP URL for that particular box, it should say hello. That's the outcome I want. I can accomplish this outcome in a variety of ways, but I want to use standardized ways of running some web servers. For example, Apache is one, Nginx is another. So I want to build out this desire that I have for Chris and I to work together on collaborating a simple structure to begin with, which is the idea that I'm describing right now. Is I want to get to a point where I can assemble a Docker file, and the Docker file should result. Sorry, it's not a lowercase Docker. It's capital Docker, capital D. That's important. So it has to be capital Docker file. You have to write a file and then build an image. That's what you will receive is an image. Then you take that image and push it to Docker Hub. Then you have an image ready on the hub. That's it. The push is the command to do that part. The build action is the action or the command to build this image out of a file. So you describe what you want here and you say build. So it builds an image. When you say push, it pushes the image here. That's it. It's very simple. When you want to use that image, you pull the image. And when you want to use it, you say run that image, this image. That's the usage pattern. It's fairly simple to think about. The commands are the build action, the push action, or the development commands. The usage commands are pull action and the run action. These are the usage commands. Usage. These are more focused developing. So build and push, or pull and run. That's the command sequence that we will follow through right now. But what do we want as a result? We want a result to be something like a page open up and that says hello. That's what we want. And we want to have this page render from a file called index.html. And it should render from a web server. And the web server that I want to choose is Nginx. So I will simplify my work. How do I simplify my work? Is to not worry about setting up Nginx itself, but instead use Nginx. Because there are people that know more than I do, and they have done the work already for us. And so this image already exists. So why bother? I mean, I'll just go and ask them, hey, will you please? And people have already obliged. Let's go see that. We'll go to Docker Hub and say, hey, do you have an Nginx image? And they'll say, yeah, we do. hub.docker.com. We'll go there and say, hey, do you have an Nginx image? And they will tell us, yes, we do. So here is how you search Nginx. And it will give you a result. And here is the official Nginx image, by the way. It's official because it was created by the people who develop Nginx. And that is the version developed 10 days ago. Nice. How do you pull that image? You go Docker pull Nginx. That's it. So we will pull that image. Now, which version do you want to pull? You can pull 113, 112, or maybe sometimes older than that. But we'll go with the latest. Okay, we got the Nginx image, but how do we use it? Because we want to actually put our own HTML file there, right? So that it says hello. So I want to see how to use that Nginx image. So I'll again ask them, hey, how do you use this thing? So Nginx guys, please tell me, how do you use it? So they'll tell you how to use it. And here it is. It says that somewhere here. It can be sometimes cryptic to read. And so that's what I would like to do, is to simplify for you. And I will read this for you, and just a minute, simplify, and then paste it out for you. So here is that line which actually has the answer to our question, and I will copy it and take it to a place where we can actually read and interpret and understand. So I'll go back to our workstation. In that Chris Taylor folder, I will open it up in Atom. And here is our Atom editor opening up. It's called Chris Taylor. And in that file, I'll open it in that folder. I'll open a new file and paste whatever I copied from that location from Docker Hub, and then understand what this does. That's what I want to really accomplish, but in the context of a Docker file. So it goes like this. So in our example, what I'm doing is basically copying and pasting some cryptic elements from that website. But what this tells me is that I should construct my Docker file that goes and looks like this. To begin with, it uses Nginx. And I will save this as is for right now. In the user folder, the name is Chris Taylor. And I will go in inside that and save it as Docker file. I'm starting to build my Docker file right now. I'll say begin Nginx as my beginning point. And then it gives me an Nginx server already, by the way. So I don't have to spend time and effort and energy in setting up Nginx because the guys did it for us. So I don't have to worry. Next, what I want to do is place my file in the right spot. So I look at that documentation and I find some references like this, which is basically telling me how to construct. They don't write these things sometimes clearly, but that's what they essentially mean, is copy something from somewhere to some location. Now, what do you want to copy from where and to what location? This is what it basically means. You copy index.html to that location. But where is index.html? So you create one if it doesn't exist, and make it say hello, and save it in the Chris Taylor folder in the name index.html, like that. So we have a file called index.html that says hello. Good. I'm going to close it. And then I have this simple Docker file. It says begin with the, begin on the shoulders of the giants. Nginx developers themselves have created an image called Nginx for us, and we are going to just use it. And then what I want to do is take my index.html file, copy it in the right location, put it inside the container at the right spot. That's what I want. Then I'm done. So this is my Docker file. I will save it and close it. And then ignore all this copy and paste that we did. But I want to run it now. So how do I run it? Well, first of all, before I run, I want to construct an image. So that Docker file is what I want to use to construct my image. So I will build an image first before I run it. So I will build my image like so. What I will do is close out this one first, remove project folder and quit this one. And in my Chris Taylor folder, I will put that on the other half. So here we go, terminal. In one half, Chris Taylor. And in the other half, we have Docker file that looks like this, with 2 lines. Line number 1, begin with Nginx. Line number 3, copy my index.html in the right spot. Boom, done. We are done. As simple as this can be the result. Now, this is a Docker file. We have to build an image. How do you build an image? You go here in the command line and say Docker build what? Build this thing, whatever I have in this folder, right here and right now, dot, this location. Whatever is here in that folder, build it. So it builds. It is going to build right now. It is going to go to the file called Docker file and read. First thing it finds, it says from Nginx. That means I need to build something using the Nginx image. And let's see if we have Nginx image locally available. No. So let us pull it from the library. It pulls that image down. And then download completes. And the first action completes. Step number 1 finishes. Step number 1 was from Nginx. You don't have Nginx right here on this box. So you pull down the Nginx image because that's what is needed to build your foundation. And then comes step number 2. Step number 2 is line number 3 in the HTML, in that Docker file right there. Line number 3. What does line number 3 do? Copy this thing and put it inside the image. Copy what? This. What is this? This is what you want to show, right? That thing. So copy this, put it in the right spot. So it does. Copied. And your image is ready. Here is the image ID. But this image ID is kind of difficult to remember, right? So I want to make it mine. I want to tag it mine. So I'll tag this image. So tagging is another build step. You just have to say Docker build -t. Keep the dot in there. I want to keep the dot, but I want to give it a tag name. The tag name I would like to choose is my company name followed by mine. I just give a random name, mine. This is mine. So mine followed by a dot. So it builds the Docker image, puts my tag in there. So I have a new tag. It quickly builds the whole image with it. Basically, it does nothing. It just reuses whatever we have done before and puts a tag like that. It says, yeah, I successfully tagged the machine image. It's not by, oops, it's not a machine image. It is absolutely, remember, this is not a machine image. It's a container image. It's a Docker image. It successfully tagged Cloud Genius mine / latest as the machine image that I just created. So I can see my images. We have an image called Cloud Genius /mine, the one I just created 2 minutes ago, and another image called Nginx, which was created 12 days ago. So this Nginx image I did not create. It was created by the Nginx developers. And so I want to just use my image. So that is what I want. So I want to push this image now. I have image ready. So I want to push it. Where do I want to push? To my Docker registry. Currently, I am using the Docker Hub as my Docker registry here. This is Docker Hub where I need to log in. So I will log in. You need a login there. Docker Hub is free, by the way. So I need to log in here. I need to grab my password, which I don't remember, but I will find out my password and type it here eventually. And so I want you to remember that Docker Hub is free, but some companies, like, Boeing company doesn't want to go public and outside. They want to keep it inside. That is okay. You can run your own Docker registry inside your company. And you don't have to go to Docker Hub and all that because people don't want to go there. Don't go there. As simple as that. So I'm going to find out my password and type it right now. And my password is usually longer, and I am going to manually type it because apparently I don't have it in my software. Okay, I logged in. And so this is the place where I want to push. Ouch. I did not save my password in. I have to type my password again, apparently. So I had to somehow tell my workstation what is my Docker password. You do that by saying Docker login followed by Docker push. That's what we really want to do. But first, Docker login. So Docker login, and my password is whatever I'm going to type right now. And that password is unfortunately very long, but that's what I am dealing with right now. So 3, there you go. Okay, login succeeded. Nice, good try. So login success. Now I have to push my Docker image. So I can push my Docker image. Which one? I want to push this one, Cloud Genius mine. So I'll say Docker push. If you attempt to push an image where you don't have Docker Hub privileges to push, it will refuse to push, which means you need an account. So I have an account. Our account is free, but you need to create an account. So I'm going to push this image called Cloud Genius /mine, and it pushes. Now this image, what I want to do is pull it on the actual cloud host that we have. And it is pushing. I'll let it push. And it pushed successfully, so that this machine image that I created called Cloud Genius /mine is ready in the Docker Hub. Let's go find it. We'll go here in our repository in Cloud Genius, and we should be able to see my image that I just pushed. It's called mine. So I'll search for it. Mine is right there. It was pushed. Come on, Yeah, it was pushed a few seconds ago. And that is how you pull it down and use if you want to use. So I will pull it down on a Docker host I have here, for example. Yeah, one of these guys. So I'll go one of these guys, say copy, and there in that box, I want to connect to that box. So SSH root at IP address. And in there, I will pull down my own image. How do I pull? Docker pull Cloud Genius / mine. So it pulls my own image coming down to that Docker host right now. So now I have an image. Let's go see what do I have. Docker images. I have a Tutum WordPress image and a Cloud Genius mine image. I want to kill this guy. I don't want to run it. Like it is running. It's going to conflict with my machine, right? My image. So I want to kill it. So I'll say Docker PS. Who do you got? So you got Tutum running there. So I will kill it. Docker rm-f. It kills. So Docker ps-a shows me nothing. And now I'm ready to run my own image. How do I run my image? I run it as simple as Docker images. I find out the name. The name is Cloud Genius Mine. So I will use that name and say Docker run, and then -d -p 80:80 port mapping, port number 80 from the container to the machine outside, and say take my image and run. There we go. So we now have on this box running a container that runs my image that I just created 7 minutes ago, right? But what does it do for us? It should show us the words hello when we visit this website represented by that IP address. So we should go open that website. This one, copy, new tab, paste, and enter. And what do we see? We see hello right there. So that's what we did. It's fairly simple. It is not complicated. You just have to understand the steps and then follow it. It's actually fairly simple if you think about it. Let's recap. So in our beginning, when we said my goal is to create a page that shows just hello, right? Very simple. And so we began creating a Docker file here. Then we built it, we pushed it to Docker Hub. Then we went to our Docker host, we pulled it down and we ran it, and we had success. The result that we expected was this hello showing on a page. We were able to accomplish that by putting a file like this alongside the Docker file as we build it. Now, when we build something like this, the image will contain this file right in the image itself. And it will go when you push it, and it will come down when you pull it, and it will show up when you run it. That's why you see this index.html showing hello when you run your Nginx web server, which, by the way, is ready and given to us for us to use in form of a Docker image. Who created that? I did not. The Nginx guy did. All I did was added my piece to it as I build my infrastructure imagery for my container images that I want to run in my cloud that I configure using this thing. What was that thing? This role that I have, which I got from the Galaxy. It was a ready-made Galaxy role that I used to convert my Docker, any random machine I have, into a Docker host. And then once I have Docker, it's all fun. It is actually fun. You will see why I say that. And we will build these examples and build more concrete things for us to accomplish in the architecture segment, which starts when? Next day, right? Next day, whenever it is, like 2 days from now. So today is what? Monday. So Wednesday we start architecture. Is that right? I think so. And in the architecture segment, we will discuss a couple of things. We'll do a couple of case studies quite in depth, and then begin to understand a variety of usage scenarios of patterns that are, or design patterns that we can reuse. And that is something that I want to talk about, is as we build the understanding of a larger scale architectural solution for a given customer scenario, we want to begin with small components that we can fit together to construct a bigger picture solution. And that is what we will begin doing from maybe 2 days from, or 3 days from today. And the second or third day, we'll start doing those things in the architecture segment. We'll begin with a case study and understanding what is and how the company called Netflix established its entire operations on the Amazon cloud, and how they go end to end delivering what you already know as Netflix. You've seen that, you use it. But we will go into deeper in understanding how does Netflix actually work? How does it make it run? We'll have an elaborate discussion in depth with great level of detail to help us understand how does that company do it. Then we can take a couple more cases of various different companies in terms of understanding what does it go to deliver a complete comprehensive solution end to end from a customer's point of view in the context of using cloud. And we'll then dissect those things into smaller components that we can reuse. So we have to understand a variety of usage scenarios at a micro level, and then put these micro components together to formulate a bigger picture solution. And that is what we will continue to do. We'll shift gears a little bit as we transition into the architecture segment. You will see that first thing first, I want to expect you to be more interactive, at least in this segment, which requires interaction and more questions, I expect, than the DevOps section. We did not have too many questions because you're mostly watching and following along as you do things to understand. And that is what I intend to cover as we go along. We'll begin with a case, two or three case studies, and then we'll go into understanding these architectural design patterns. We'll apply them to using Docker or using other solution sets that are available out there. We'll also use CloudFormation from Amazon. We'll use Terraform in the open source. We'll apply these tool sets to understand how can we orchestrate a complex architecture in the context of using a variety of clouds. And we will not limit ourselves to just one cloud or two clouds. We'll just pick your cloud and work with it kind of scenarios. We'll also do, depending on how much time we are able to gather, there is more content I have in the architecture segment that we have built up recently. Again, it is not written down in form of write-ups, but I have ready exercises that we can play with in as we go along in the architectural segment. So we'll discuss more of these things as we go. But for right now, I will pause for questions and also pause the recording on this. So we will have a video file at the end.